So today we're going to solve compound and absolute value inequalities. We're going to start with compound inequalities. They should look familiar to you from Algebra 2. So if you're looking here, we have x is less than or equal to 2x minus 3 is less than 15. You'll notice you have two inequality symbols in there, which makes that the compound inequality. Because this is written as all one statement, that's an and situation. If you have it written as two statements and the word or in the middle, that's the or case. We're going to take a look at solving this and situation. We solve just like you would a normal equation by getting x by itself. So our first step to get x by itself, we need to get rid of minus 3. So we're going to add 3 on all three sides. Be careful, you got to put it on all three sides. When we do that, we end up with 11 is less than or equal to x is less than 2x is less than 18. So we need to solve for x. We still need x by itself, so we've got to divide all three sides by the 2 to get rid of 2 times x. When you divide by 2, we end up with 11 halves is less than or equal to x is less than 9. This is actually an answer. This is one way of writing that solution. We actually have another way of writing the solution with the word and in the middle. Let's take a look at that. To be able to write it with and in the middle, you'd break this up into two parts. You'd have the left part and you'd have the right part with the word and in the center. 11 halves is less than or equal to x, and x is less than 9. Because we usually have x on the left side, you would also flip over that inequality with the x on the right side. Remember, you have to flip not only the values, as you also have to flip over that symbol. So this is a second way that you could write this and statement. We also can graph this on a number line. So when we graph it on the number line, the smaller number always has to be on the left-hand side, bigger number on the right-hand side. To graph it, we'd start with the part x is greater than or equal to 11 halves. At 11 halves, because of the equal to, we would put a circle to show that we're including it. We would fill that circle in. Greater than, you'd shade off to the right. X is less than 9. 9 is not included in that part, so we'd have an open circle. Less than means you'd shade it off to the left. And means you look to see where the answers are overlapping. So they have to be in the same spot on both. So notice it's 11 halves is included in the top part and in the bottom part, so 11 halves is part of the answer. You fill it in. On the 9, this one has an open circle, which means it's not part of the answer. You would have an open circle at 9. Then it's overlapping here in the center, so you'd shade everything in the middle. So our answer on this one is filled in circle at 11 halves, open circle at 9, shaded everything in the center. As far as an OR case is concerned, you're not looking to see where they're overlapping. You're going to take all the values for the solutions with OR cases. Let's move on to solving absolute value inequalities. We use the critical point method to solve them using a graphical approach. So first, what is the critical point method? We find critical points two ways. One, by replacing the inequality with an equal sign and solving like normal. The second way you can also get a critical point is if you set if x is in the denominator, you set the denominator equal to 0 and solve for x. Those are also critical points. So our actual steps on solving these absolute value inequalities, we're going to first find the critical points. Then we place those critical points on a number line. From there, we have to decide where our actual solutions are. So we're going to graph the equation, put it in our graphing calculator, and depending on where those values are located, it's going to tell us if we include it in our answer or not. For example, if we have the less than symbol in our inequality, a less than symbol means where the graph is below the x-axis, or where our y values are negative in a set of table of values. If we have is greater than symbol, greater than is where our graph is above the x-axis, or where our y values are positive in a table of values. If we have an equal to equal to is where the graph is on the x-axis as x-intercepts, or in a table of values, your y value is 0. When we are solving, we are using the critical points, and if any of those critical points come from the denominator of a fraction, they are never part of the solution of that inequality. So let's take a look at an example. So we have the absolute value of x minus 5 is greater than or equal to 18. So we're using the critical point method. There's no denominator, so we don't have to worry about that. But doing critical points, we're going to pretend like that inequality is an equal sign. So let's rewrite it with an equal sign. And then we solve it like normal. If you remember from earlier, we solved absolute values by breaking this up into two different parts. We break it up into two different parts by dropping off the absolute value on the first equation. The second equation, we drop off the absolute value, and we're going to change the sign on the 18, so we're going to make it a negative 18. At this point, we solve for x like normal. So you're going to see that we need to get rid of the minus 5 by adding 5 to both sides of that equation. And I'm going to go ahead and do it to both of them because that's the same process over there. Once we add 5, we get x equals 23. And we get x equals negative 13. These are what are called critical points. We're going to take those critical points, we're going to put them on a number line. Make sure you have your smaller number on the left-hand side. At this point, we're going to use our graphing calculator. So we go up here to where we had the equal sign in that second equation here, and we're going to type this into our graphing calculator, but we're going to plug it into the y equals part. So we need to get rid of the equal sign. We do that by moving that 18 over to the other side by subtracting it. So in our graphing calculator, we're going to type in y sub 1 equals absolute value of x minus 5 minus 18. So everybody pull up your calculator, and your y equals, we're going to go math. To get our absolute value, you have to hit the right arrow over, choose absolute value. And now you're ready to type in your x minus 5. And then right arrow over to get out of the absolute value. Now if you have an older calculator, your calculator is going to write ABS with a parenthesis. That parenthesis is telling you to put the x minus 5 inside and then close the parentheses. Then we're going to type in minus 18. And we're going to hit graph. I'm putting mine on my standard window by hitting zoom 6. You guys could just click on the graph, and you're going to see that we should have that V-shaped graph, and we're not seeing that V, we're just seeing part of it. So why is that? When we went to solve, we found it's going to touch the x-axis at negative 13 and at positive 23. Our standard window goes out 10 to the left, up 10, down 10, and to the right 10. So if we're touching at negative 13, it's off our screen. If it's touching at positive 23, it's off our screen. So we're going to go change our window, and we can change it to whatever we want. But if we want to go off to the left, those are your x values that you're wanting to change. To the left is your min, to the right is your max. We know to the left we're touching at negative 13, so why don't we go a little further and make it negative 20. The x max, we were going off to the right and touching at 23. Let's make it a little bit further and let's make it at 30. So then go ahead and hit graph, and you should see that V a little bit better. If you wanted to see the bottom of the graph, you would change your y min value. Alright, we see enough though. It does look like it's crossing here at negative 13, positive 23. We can double check using our calculator. Second, calc. We want to find where it's touching the x-axis, so value, and you're going to type in your negative 13. You should see a y value of 0. So basically we just checked our work. When we solved and got a negative 13, we solved it correctly. You could also type in the 23, and notice it's also got a y value of 0. So we solved that inequality just fine. So now we're going to take this and we're going to make a quick little sketch on our notes. So everybody go ahead and go back to your number line, and we're going to make a sketch of that V. So it was coming down, it hit at the -13, and you got your V, and then it goes back up and goes through the 23rd, or 23. So notice on this, it's just a sketch. Mine's not perfect. If I could sketch it better with a straight line, that would be even nicer, but I got a little squiggly in there. Alright, so at this point we've got our sketch. Now we actually need to get our answers, and our answers are coming from looking at this inequality sign. So the equal to means we want to know where does it touch the x-axis. We are touching the x-axis at -13, so we want that part of the solution, so we're going to put a filled in circle. At the 23, it's also touching the x-axis there. It's an x-intercept, so we got a filled in circle there as well. If this was not an inequality that has the equal to, we would have open circles at both of those values. So then, you see the symbol that is greater than? Is greater than means we want to know where is our graph above the x-axis or where our y values are positive. We have two locations. We have over here and over here, because that's where it's above the x-axis. Now when we name our answers or our solutions, we don't use our y values to do that. We use our x values. So think of these as being ordered pairs, x comma y. We're wanting to know what are those x values. Well, in terms of our number line, our x values are all the numbers that are less than -13. So that's part of our answer. X is less than 13. Because we put a filled in circle there at 13, we also want to include the 13, so we're also going to put the equal to symbol. Over here, it's all of our x values. Remember, x comma y, our x values go off to the right. So when our x values go off to the right, it's all of our x values that are greater than 23. But because we have the filled in circle, we also want to include it, so it is greater than or equal to 23. Because of our answers being split like this, it's actually an OR case, so we need to have the word OR in the center. Alright, so there is our first example. We're going to stop there. I think my next one's going to take more time than I have left, so you'll watch the next video in just a few.